Hi everyone! So in this video, we're going to be learning about a specific type of function called a piecewise function. We'll also be talking about absolute value and absolute value functions, and we'll see that there is a relationship between piecewise functions and absolute value functions. So remember that last time, in the last video, we saw that functions can be determined by a formula, right? So we saw that you can have functions determined by different, we saw tables, formulas, and we also mentioned graphs. But we focused a lot on functions determined or described by formulas. And so what I mean by that is something like f of x is equal to x squared plus 5, right? That's a function defined by a formula. And the way it works is that when you want to find the output for a specific input, you just plug the input in for x, right? And so what we'll see in this video is that there are some types of functions where it's not enough to just have one formula. Some functions, in order to describe all of their different parts, need multiple formulas. And so that's what's going to be called a piecewise function. So in this video, we'll see that there are some functions that are described by multiple formulas. And we'll see that these types of functions are called piecewise functions. So I'm going to jump right into an example because I think that's really the best way to see how these work. So, again, as with the stuff in the last video, there's a good chance this is review for you. You probably have seen this before, but I have felt like piecewise functions are one of the topics that students tend to be a little bit less familiar with compared with other function stuff. So I'm just going to write down an example of a piecewise function, and then we'll talk about how it works. Okay, so piecewise functions always have kind of this structure to them where you're given multiple kind of formulas, right? So we have 2x plus 1 and we have negative x plus 5. They're all kind of like listed out. And then we have this kind of bracket symbol that kind of just collects them all together to be like, hey, look, these are all kind of a part of the same function. And then a really important part of a piecewise function is what's going on over here. So you want to think of piecewise functions as kind of like instructions. And they're instructions that are telling you that depending on what your input is, you're going to use a different formula. So what this part is telling us, so it says 2x plus 1 if x is less than 1. And so what this part here is telling us is that we're going to use the formula f of x is equal to 2x plus 1 for inputs that are less than 1. And then what this part is telling us is that we're going to use the formula f of x is equal to negative x plus 5 for inputs greater than or equal to 1. So basically what this means is that depending on what number you're trying to plug in, that's going to tell you which one of these formulas you're using. So for example, let's say that you're asked to evaluate f of 0. So if you're asked to evaluate f of 0, the first thing you need to do is figure out which one of these two formulas are you actually going to be using. And the way that you figure out which formula you're going to be using is you want to start by looking over here actually, right? You want to start by looking at which of these ranges does this x value fall into. So for this one, because our input is 0, 0 is less than 1. right? And so that tells us that we need to use the top formula. So we're going to use the first formula, and that is because our input 0 is less than 1, right? It falls into that kind of first category. So how do we find f of 0? Well, our first formula, the top one, tells us that f of x is equal to 2x plus 1. So we would say 2 times 0 plus 1, and we would get 0 plus 1, which is 1. So f of 0 is equal to 1. Okay, so what if now instead we're asked to find f of 3? Well, in this case, again, you want to start by looking at this part. You want to first figure out, which one of these ranges does this number fall into? So our input in this case is 3, right? And so 3 is a number that is greater than or equal to 1. And so we're going to use the second formula, and that is because 3 is greater than 1, right? And so this formula tells us that we're supposed to use the second formula if x is either greater than or equal to 1. And so in this case, it's greater than 1. 3 is greater than 1, and so that's what tells us we use the second formula. So to find f of 3, we're going to plug into the formula that tells us, sorry, my screen is a little stuck, negative x plus 5. So we have negative 3 plus 5, and so we get 2 as our answer. So f of 3 is equal to 2. Okay, so last one, let's say that now we're asked to evaluate f of 1. So notice that 1 is kind of our like transitioning point, right? Both of these have a 1 in them. And so that's where the less than and greater than or equal to, that's where like the equal part of this kind of comes into play. So we'll talk a little bit more about inequalities in an upcoming video. But basically, if you have an inequality symbol that does not have a line under it, an extra line, that means that whatever number you're kind of comparing to is not included. So you're only supposed to use this first equation, this first formula, if your input is strictly less than 1. So there's no equal sign here. So that means that you only use that top formula if x is less than 1. On the other hand, if we look at the bottom formula, this one tells us that we can use it if x is greater than or equal to, right? That's what that bottom part means. And so if x is greater than or equal to 1, we're supposed to use the bottom formula. And so in this case, we're trying to plug in 1, and so we need to use the second formula. So this sentence is going to look a little bit silly, but we're basically using the second formula because our input is 1, and 1 is equal to 1, right? Because our instructions tell us to use this if x is greater than or equal to 1. And so it is equal to 1. And so that's why we're using this formula. And so we plug 1 into our formula, which said negative x plus 5. So we have negative 1 plus 5. And so we get an answer of 4. So that's really it. Like piecewise functions, I think students get a little overwhelmed with them because they kind of look different, right? They have a little bit more going on with them, but really just think of it as instructions. Just think of it as instructions and focus on this right-hand side to figure out, which formula are you using? And that's really the only tricky part, is just deciding which formula you're using, and then you can plug into that formula. So let's look at another example of a piecewise function. So this piecewise function says g of x is equal to, so we have x squared if x is not equal to 2, and then we have 5 if x is equal to 2. So just like the last example, you can think of this as a set of instructions. It's a little bit different, but really the idea is very similar. So in this case, this is telling us to use the formula g of x is equal to x squared if the input is any number other than 2. I'll say that as besides 2. Right? It's basically telling us, think of this as instructions. It's telling us use this formula x squared if x is anything other than 2. As long as x does not equal 2, you're going to use the formula x squared. And then the second part is telling us to use the formula g of x is equal to 5. So that might seem like kind of a funny function. We'll talk more about this type of function a little later. This is what's called a constant function. So it's a constant function because no matter what number you plug in, the answer is just 5. And so this tells us to use the function g of x is equal to 5 if the input is 2. Okay, so let's evaluate a couple of examples here. So for example, let's say that we're trying to find g of 1. So which formula are we going to use here? Well, we're going to use the top one, right? We're going to use the first formula. And that is because the input is 1, and 1 is not equal to 2, right? For any number that's not 2, we're going to use that top formula. And so that means that g of 1 is going to be equal to 1 squared, which is 1. Okay, what about if we wanted to evaluate g of 1.999? So notice that, again, we're supposed to use the top formula for any number besides 2. So 1.999, like that's pretty close to 2, but it's not 2, right? It's a different number. And so we're going to still use the first formula because 1.999 is not the same number. It's close, but it's not equal to 2. And so we would do g of 1.999. We use that top formula, which says that we take our input and square it. And so 1.999 squared, this is one that you probably are going to need to do on a calculator. So 1.999 squared is equal to 3.99601. And then finally, well, if we actually wanted to evaluate g of 2, so that's the one where we use the bottom formula, right? So use the bottom formula, or the second formula, because, well, 2 is equal to 2, right? Because we're actually plugging in the number, the special number this time. And so what does the second formula tell us? Well, it says that it's just 5, right? The output is just 5. So g of 2 is just going to be equal to 5. So there's not really any like algebra or anything to do, or arithmetic to do, it's just equal to 5. So for piecewise functions, you can have more than 2 formulas. So you could add on kind of a third formula and then a different range for x. I'm not going to do an example like that just because it's very similar. I'll put an example like that on the worksheet so you can check whether, kind of confirm that you understand how that would work, but it's very, very similar to how these work. What I do want to show you is, why do piecewise functions exist? Like, why would we even, make these kind of more complicated functions? Well, because in the real world, frequently, like situations will change depending on the quantity that you're actually looking at. So I just want to give you a quick example of how a piecewise function could show up in the real world. So let's say that you're shopping at Fred Meyer and they have a sale on their bulk granola. So Fred Meyer has a special sale on bulk granola. So bulk, I just mean like, the bins where you can go, they're probably closed for COVID right now, but where you can go and scoop out the, whatever amount you want and buy that is what I mean when I say bulk. So their deal is that if you buy 3 pounds or less, the granola costs $5 per pound. So that's not really the sale part. The sale part is if you buy more than 3 pounds. Well, then the granola price goes down. It goes down to $4 per pound. Oops. And so the question I want to answer here is I want to write a function f of x that basically gives us the cost of purchasing X pounds of granola. So why is a piecewise function going to be the type of function we need to use here? Well, basically because the situation changes depending on how many pounds of granola you're buying, right? So if you're buying like 2 pounds, well then you would calculate the cost one particular way. But let's say you're buying 5 pounds, then you're actually going to calculate the cost a completely different way. So we need to kind of take that into consideration, and that will mean that we'll have 2 different formulas. Okay, so we're going to have a piecewise function, like we said. So we're going to have f of x is equal to, and I'm actually going to kind of leave blank the 2 formulas to start with. Let's start by putting in the kind of if x is part, because I think that's actually kind of the easier place to start in this case. So what are what's kind of the place where the calculation changes? Well, the first one says 3 pounds or less, and the second one says more than 3 pounds. And so it means that 3 is really our kind of turning point where we're going to kind of switch from one formula to the other. And so the first one is going to represent this top situation, right? Where if you buy 3 pounds or less. And so that means that we're going to be looking at an amount of granola that is less than or equal to 3, right? Because it says 3 pounds or less. So that's less than or equal to 3. Whereas the second part here, that's going to be when you buy more than 3 pounds. And so that is going to be when your quantity of granola is greater than 3. And so now the next question is to figure out, what's the actual formula here? So let's focus first on the first part of the formula. So if you buy 3 pounds or less, granola costs $5 per pound. So if granola costs $5 per pound and you're buying X pounds of granola, that means that you're going to multiply 5 with the number of pounds. Right? For example, if you buy 2 pounds of granola, you would do 2 times 5, which is 10. On the other hand, if you're buying more than 3, so this was our first part. Now let's say you're buying more than 3 pounds. Well, now the rate changes. So now it's $4 a pound. And so that means that we're going to be doing 4 times the number of pounds instead of 5 times the number of pounds. So let's make sure that this kind of makes sense. So for example, if you're buying 2 pounds of granola, as we said, so f of 2 would mean you're buying 2, I'll say that this way, it's the cost of 2 pounds of granola. Well, 2 is less than or equal to 3. And so, right, we're going to use the first formula. And so f of 2 would be equal to 5 times 2, which is 10. And it would be $10. And that makes sense, right? Like just without having written down this function, you would have been able to say that. If we buy 2 pounds of granola and they're $5 a pound, it should be $10. Let's say now that we wanted to evaluate f of 5, f of 5 would now be looking at the cost of 5 pounds of granola. And so for this one, we want to use the second formula, right? Because 5 is a bigger number than 3. So that points us to the second formula. And so the second formula is 4 times x. So now we would have 4 times 5. And so we would get $20. I don't know who's out there buying $20 of granola, but I guess 5 pounds is a lot of granola. Maybe that's for like, a large family or something. So I just wanted to show you this because, there are a lot of real world situations. Think about, like the way that cell phone bills work, or there's just so many things that you purchase where the rate that you're paying depends on the quantity that you're buying. And so those type of situations are really the reason that we need piecewise functions. Okay, so the next thing we're going to talk about is, like I said, at first it's probably going to seem unrelated, but then we'll see how it actually is related. So we're going to be talking about absolute value functions. So absolute value functions. So I first just want to remind you what the absolute value symbol means. So if a is any real number, if you put these kind of vertical bars around a, so the way that you would read this is you would read this as the absolute value of a. That's like how you would pronounce that, that symbol out loud. I'll put it in quotes. What does that mean? What does that symbol mean? It basically means the distance that that number is from 0. And I'll kind of explain a little bit more what I mean by the word distance. But it's the distance from your number to 0. And so when I say the word distance, distance always refers to a positive measurement, right? Like if someone asks you, what's the distance from your house to school, you wouldn't say -3 miles. That doesn't make sense, right? So the word distance assumes positivity. So distance is always a positive measurement. And so, one thing that you might remember about absolute value is that it makes numbers positive, and really this idea of distance is just like another way of saying that. So for example, let's say that you're supposed to find the absolute value of -5. The way you can think about that visually is if you make a number line, and so you have 0 here, and you have -1, -2, maybe let me give myself a little more space. Okay, because I want to actually multi-purpose this number line for something else in a moment. So -1, -2, -3, -4, -5. Barely fit it on there. So if we're looking at the distance from -5 to 0, that's basically asking us, this measurement here. And so the distance is 5. Even though it's the 5 is negative, the actual distance itself is equal to 5. Now, if we do the same thing with +5, so that would be over here, 1, 2, 3, 4, 5. Well, even though it's in the opposite direction, the distance from 0 to 5 is still the same, right? It's still +5. Like the actual distance itself doesn't matter whether it's to the left or the right, it's still a distance of 5. So, I think maybe I like this idea of distance as kind of your initial introduction to what absolute value means, but in practice, you'll probably just think of it as take your number and make it positive. One kind of interesting example is, what is the absolute value of 0? Well, what's the distance of 0 from itself? There is no distance, right? If someone asks you, how far are you from home, and you're sitting on your couch, you would say, I'm 0 miles from home. And so the absolute value of 0 is just equal to 0. Okay, so we can make a function using the absolute value symbol, right? And so let's look now at an example of a function. F of x is equal to the absolute value of x. So that is the absolute value function. And so how does this function work? Well, it works just like all the other functions we've seen. You plug numbers in, right? So for example, let's say we wanted to find f of negative 3/4. Well, that would be equal to the absolute value of negative 3/4, which is equal to 3/4. And if you wanted to find f of positive 3/4, well, that would be the absolute value of positive 3/4, and that would also be equal to 3/4. So, basically when you have an absolute value function or the absolute value symbol, plugging in a negative and a positive give you the same result. So I want to kind of connect this back to piecewise functions. So the absolute value function they can be expressed as piecewise functions. So I want you to pause the video, and again, as I mentioned in the last one, I really encourage you all throughout, pause the video, anytime we're working on a problem, just try it yourself first. But now I explicitly want you to pause, and I want you to think about how could you express the absolute value function as a piecewise function. So think about, if you wanted to write down a formula for absolute value that did not involve the absolute value symbol, what are kind of the two different situations? Like certain numbers are treated differently in the absolute value function than others. Think about, what are those two different types of numbers, and what might that point you towards as an absolute value or as a piecewise function? Okay, well, what is kind of the dividing point as to like how you treat different numbers when you're taking their absolute value? Well, it's whether they're positive or negative, right? Like positive and negative numbers are treated differently in the absolute value function. What do I mean by that? Well, when you take the absolute value of a positive number, it comes out the same as it started, right? Like anytime you take absolute value of a positive number, it just stays itself. It doesn't change the number. Whereas when you take the absolute value of a negative number, it actually switches it, it changes it, it makes it positive. So there's a difference in the relationship between the input and output when you're dealing with a negative versus a positive number. So specifically, let's start with it's a little bit backwards, but let's start with the positive one because I think that is a little easier. So the positive case, and actually we'll see it doesn't matter where you put the 0. So I'm going to put the 0 with the positive case. So I'm going to say if x is greater than or equal to 0. So if you're plugging in a number that is greater than or equal to 0, it doesn't change when you take the absolute value, right? And so how do you write down a function where the input doesn't change when you find the output? Well, it would just be x, right? F of x is equal to x. So like, for example, if x is 3/4, f of 3/4 is still 3/4. And so we see x here and we see x here. Input equals the output. So that's what happens when x is greater than or equal to 0. So the other case will be if x is negative. So if you're plugging in a negative number. So what happens when you plug in a negative number? Well, the sign gets flipped, right? You started with, for example here, you started with negative 3/4 as your input, and you ended up with positive 3/4 as your output. So how could we write that? How do you write down something that flips the sign? Well, we can actually introduce a negative sign. And that probably seems really weird to you because the whole idea is that absolute value makes things positive. But the idea here is that in this top equation, we're already plugging in a negative number, right? The top equation is the one that we use when our input is negative. And so if you already have a negative number and you apply another negative sign to it, it becomes positive. And so this is just another way of expressing the absolute value function. I just think that from time to time, it will be useful to know that you can write an absolute value function this way. Usually, that's probably not the way most people think of it, right? Probably most people think of absolute value as, okay, I just take my number and make it positive. But I think it will be useful, if not in this class, definitely in a future math class, it will be helpful for you to understand that you can write an absolute value function this way. You can split it into these two different parts. Let's actually, before I move on to one last thing, let's actually kind of test this out and verify that it works. So for example, let's say we wanted to take f of -1 using this piecewise definition. So according to our kind of instructions here, we're supposed to use the top formula, right? Because our input is less than 0. So what does the top formula tell us to do? It tells us to introduce a negative sign. So we have -1. And the -1, or the two negatives together, give us a positive. So we end up with 1. And so the absolute value of -1 is +1. So it worked. That's what I meant when I said that introducing another negative has the net result of giving us a positive. On the other hand, if you plug in a positive number, let's say 2, well, when you're plugging in a positive number, you're supposed to use the second formula, right? Because you're plugging in a number that is greater than or equal to 0. And so if we plug in a positive number, we're just supposed to use the formula f of x is equal to x. And so that means that our answer would just be 2. And so both of these make sense, right, for what we want this function to do. So this piecewise way of writing down absolute value functions is equivalent to just using the absolute value symbol. So I want to just do one more example just to get a little more practice working with absolute value. This one, we're not going to write it as a piecewise function. You could write it as a piecewise function. We're not really set up to do that just yet, but maybe like later in the class, we'd have the tools we want. But I just want to get a little more practice working with absolute values. So let's say we have the function 3 times the absolute value of x minus 5 plus 1. So let's say we wanted to evaluate g of 1. So what would this look like? Well, we would just be, again, replacing x with 1. So we have 3 times the absolute value of 1 minus 4 plus 1. So the reason I wanted to do this example is just to kind of remind you about order of operation. So order of operations tells you to kind of start on the inside, right? PEMDAS is what you might have learned. So it tells you to do parentheses first. Now there aren't any parentheses here, but you can think of the absolute value bars as being kind of like parentheses. So basically we want to start inside of the absolute value. So we're going to rewrite this as 3 times the absolute value of -3. Right? I'm just doing 1 minus 4. 1 minus 4 is -3. And then what's the absolute value of -3? Well, it's +3, right? So this -3 becomes a +3. And so we have 3 times 3 plus 1. So we end up with our final answer of 10. So I'll give you a little bit more practice working with absolute value and kind of reminding yourself about how order of operations works on today's worksheet. All right, I will see you all in the next video.